by the Nigerian Society of Engineers, Abeokuta branch. My name is Tunde Olaniro, and it's going to be very interesting because, yes, last week was interesting, but today will be more interesting and enriching. You know, it's a very interactive one where we don't only get to talk to you, but you also get to answer our questions, ask questions, and get prizes courtesy of our sponsor. And we have been announcing, and I will also use this privilege to inform you that if you are an ardent caller on this show, by some selection, you are going to have the opportunity of featuring live on this program, and where you get to participate in one or two things and win one or two prizes courtesy of our sponsor, Prince Nigerian. And it's not just be you calling in, it will be you sitting down with me here and answering questions and participating in one or two activities. All right, let's get the program started. You know, this is an interactive one. So the question for today is, what is the movement of cell against concentration gradient called? The movement of cell against concentration gradient. What is it called? If you know the answer, pick up your phone and call us. And you can also drop your answers on all the social media platforms of OGTV as they are displayed on your screen right now. So what is the movement of cell against concentration gradient called? That is biology. If you know that, let us know the answer. So my guest is already with us. She's joining us via Zoom, and let's take this break. When we return, I'll let you know who she is, and we'll take it off from there. All right, welcome back. If you watched us last week, literally we just did part one, because it's the same guest I had last week that I'm having this week. Engineer UCHECHI EDOSOMWAN. She did a very good job last week, and I'm sure she's going to do a better job this week's edition. Good evening, ma. Good evening, ma.
Having me again.
Can you hear me? Can you hear me now?
Yes, I'm hearing you very well.
All right, good evening. Welcome to Engineering and You for today.
Thank you very much.
All right, let me yield the floor to you. She's talking about engineering in the aviation sector. So let me allow you have the floor and go ahead with your presentation.
Okay. Thank you very much for another opportunity. Okay, so we're going to be looking at engineering in the aviation industry. We spoke last week about how beautiful engineering was.
Yeah.
And this is a very specialized industry. It's a sector that's not very common to people. So just a quick recap, we already know that engineering is from two Latin words, ingenium and ingeniare, meaning cleverness and device. And then I believe, that's my own personal opinion, that engineering is the melting point of STEM. It's actually the reality of STEM. If you want to see, touch, feel STEM, then come to engineering. And so any engineer must be an ardent learner, thinker, and a solution provider. Right, so now let's delve into the aviation sector. It's just a picture of the airport. I already mentioned that, you know, the aviation industry is stimulating, is a knowledge-driven and highly safety-critical sector. It's one thing I love about it. You must be medically fit to work in the aviation industry. Now, from the start of the aircraft engine to its shutdown, there are processes that happen. The pilot communicates with the air traffic controller as it flies. You know, the aircraft itself communicates with navigational aids, facilities on ground. The air traffic controller also visualizes and sees the aircraft on his radar screen. And then, of course, the aircraft components, if the pilot, you know, presses a switch or a button, it responds. So all these things happen for us to know that aviation needs engineering. That you can't have aviation without engineering. So engineering aviation provides services to ensure safety, efficiency, and economy of flights. So let me introduce you quickly to the aircraft. You can imagine something that weighs a minimum of 20,000 kilograms. It's suspended per se in the sky and flying, at an altitude of almost 25,000 feet upwards at a speed of 800 kilometers per hour. That can only be made possible by engineering. All right, so there are 4 forces that act on the aircraft: the thrust, the lift, the weight, and the drag. I won't want to bore us with this. What I want to do this evening is just to make our young ones begin to look in the direction of the aviation sector. Now this is the cockpit. A lot of us may not have had the privilege to enter, the pilot's room, if I call it that way, where the pilot sits and flies from. So this is what you see. Those 2 seats are for the pilot and the co-pilot. But as we go on, I will tell you which of the engineering, flavor has to do with a lot of those things that you're seeing in the cockpit. So now the safety level, I already emphasized that it's a highly critical safety, sector. Actually, if you go for any training, like in the Nigerian College of Aviation Technology, the pass mark is 80%. And you can imagine. So if you get, because why we're dealing with lives, so we do not take any risk. And then it's also a sector where, you have to adhere to equipment, aircraft process documentation. You're literally married to documentations and manuals. So I just wanted us to have that. And then, unlike maybe if I'm driving a car, once I have a driver's license for private vehicles, I can jump into a Peugeot, can jump into, maybe a Jeep, a Toyota and drive. That's not the same way it is with aviation. You have to have a license and a rating for each and every of the equipment for aircraft. All right, so let's just quickly start. The aeronautical engineer designs, builds, and assemblies and tests the aircraft. So there are different aircraft parts that you can see from this picture. All right, the fuselage, the flight controls, the wings, and all that. So that's what the aeronautical engineer does. They do their calculations, they know the weight, they know the size and the fit, depending on the type of aircraft being designed and being built or assembled, as the case may be. And then you have the aircraft maintenance engineer. Now there are 2 of such flavors. They call them B1 and B2. So the B1 is the airframe and power plant engineer that deals with, the aircraft structure itself, the power systems, the mechanical systems. So these are more or less like the mechanical engineers, the fuselage, which is the body of the aircraft, the wings, which you see, stretched out that helps you in the flight. There are other parts, like the landing gear is underneath the fuselage that retracts when you're taking off, extends when you're landing. All those things, the aircraft maintenance engineer, B1, has to take care of those things. And then the power plant, of course, is the engine, that gives it the energy or the power that it needs, just like the name implies, to take off, to cruise, to land. Okay, so the aircraft maintenance engineer, B1, deals with anything that has to do with all these things you've seen on the screen, the elevator, the rudder, and all those things. The elevator helps it to take a pitch, and so, but the aircraft maintenance engineer, B2, now deals with the avionics. This is the one that is mainly dealing with what you find in the cockpit. The cockpit contains communication, navigational equipment. That's really weird. And then there's another compartment that's just below the cockpit that they call E&E, which is the electrical and electronics compartment. But those control switches are also in the cockpit. So you find some of these things that are listed here, like the BOR ILS. Remember I said the aircraft comes with some navigational aids on ground. We'll see those navigational aids, for instance, that this particular one, the BOR ILS, deals with, and all that. Okay, now the aeronautical telecommunication engineer, which is where I fit into. Okay, we talk about the communication, navigation, surveillance, and power systems for a safe flight. So these are the things. I'm just going to take them bit by bit, but power systems is like what it is. CNS power. Everything that you work with is powered either by solar or any other alternate power generation. So that's what the power systems engineer deals with. He has to make sure, and then the voltages are different. Some are 5 volts, some are more. Okay, but for the communication engineer, the part that the aeronautical telecommunication engineer that is a communication systems engineer, deals with voice and data. All right, communication. Remember I said from the start of the aircraft engine to its shutdown, the pilot must communicate with an air traffic controller on ground, not in the air. So the pilot is flying in the air, communicating with someone on the ground. So who makes it possible? The communications engineer. Voice and data. You know, the voice has to do with radio and telephony. And then data, we have what we call, some of it is ATS, message handling system. You know, some of it is NOTAMs, maybe notice to airmen, if maybe a runway is shut down, and all those things. So terrestrial and satellite. That's why some of these pictures you're seeing, we deal with. The voice communication and control system, you know, that gives the air traffic controller, you know, the devices that it needs to communicate and communicate well. While the VSAT does a network around the airport, because the pilot is actually flying, for instance, from Lagos to Abuja, he must talk. And so those are the things that the communication engineer does. Now the navigational engineer guides, it maintains and installs equipment or facilities that guides the pilot. This one is actually another interesting part. You know, from the first one, the DVR, which is the Doppler very high frequency omnidirectional range, you know, all these things are more or less antenna systems. You know, this one, you know, when you're driving, you know your road. If I'm going, okay, I live in Lagos, for instance, maybe I'm driving from the airport to maybe Anabaja, I know the road to take. Now, for the air, there are routes in the air, and what gives it that is the DVOR. So the pilot is not just flying in a disorganized manner. No, he knows the routes, and it's the DVR that gives the aircraft the routes, you know, to guide it. And then the next one is the glide slope. That, if you notice, I actually purposely picked this picture that has the aircraft about to land in an airport. The equipment you see that has three antennas is the glide slope. It gives the three-angle glide, you know, 3 degrees angle glide for the aircraft to be able to come down the touchdown zone. There's a part of the runway that is known as the touchdown zone. So that's what the glide slope does for the aircraft. And then the localizer is usually at the end of the runway. It helps the pilot to be able to locate the center of the runway. That's why you see a lot of aircraft flying and, you know, landing properly and safely because of all these navigational aids on ground. And then the third one I will speak about, because I'm wasting my time, is the surveillance system. You know, this one is another interesting part. What you're seeing on my left, like co-located primary and secondary radar system, all right? And what it does, like, the primary one is any target. So anything in the air, anything in the sky, it's depending on the range. It doesn't go too far, like 5 miles. So while the secondary has what we call a transponder that must be in the aircraft for it to be able to give us, you know, proxy identification. What would we mean by proxy identification? Like the primary, the bird, anything in the sky. But the secondary radar system will actually use aircraft for you. Why? Because it has transponders, and so they will know the call time, the speed of the aircraft, the location. So the aircraft control is able to do an informed control, if I should use that way. So what you see on the other screen is the display, you know, when the radar system is working. Finally, some of the other ones you have, like the airport and aerodrome engineers spoken about, so they design the airport, because it's not just location, everything is by design. Everything you bear it in mind that, oh, where's my runway going to be, where's my taxiway going to be, where are the terminal buildings, the control tower, and all that. The control tower must be in a location where the air traffic controller sees and controls properly. And then the safety engineer, most of them work with the civil aviation authorities where they deal with documentation and oversight functions. They are inspectors. They make sure that airlines and, you know, agencies in the aviation industry keep to the documentation, the rules, and the regulations. And then the IT network engineer, everything now is IT, everything is network. And so that's what they deal with. The networks, they maintain it, they install it, the cabling, and all the things that we require. And so in conclusion, there's a quote I like. I didn't mention a certain quote at the beginning. I may go back and see that. But this last quote says, if you want to work in engineering and have an impact that is global, come work in the aerospace sector. I laughed when I saw this because this is true. If you really want, because like the first, if I can remember that first quote very well, it says, with the aviation, with flying, you can believe that anything is possible, because if I can lift and sustain a 20,000 kilogram weight in the air, defying gravity, then anything is possible. All right, and that's the beauty of engineering. We make you know that there's nothing impossible. But the engineer doesn't have the word impossible in his dictionary. All right, so if you want to work in a place that you have the impact that is global, come to engineering and come to the aerospace sector. But I would recommend for our young ones, I would advise, based on the experience I've been in this industry for I think 25 years, I'm not sure, but about that, and I would advise that they go for the basics, the mechanical, electrical, electronic, software, and computer engineering in the university before you come into this specialized engineering field, so that it gives you a really good foundation to build, right? And then, of course, engineering is critical to development for any nation, and I would like to say that engineering in the aviation industry hastens the arrival of that nation to its developmental goals. So if you're still undecided, and then you see I'm wearing my reflective, because in the aviation, engineering particularly.
All right, we have Engineer UCHECHI. I'll have to hold on a little bit. We have a caller. Glory, good evening.
Good evening, sir.
Good evening. How are you? How is Moe today?
Moe is fine.
All right. Do you want to ask my guest a question, or you want to answer our question?
Don't answer the question.
All right. Go ahead.
That the answer is active transportation.
All right. Thank you very much, Glory. I'm sure you two are developing interest in aviation engineering.
Yes, sir.
All right, Glory. Thank you so much for watching. All right, Engineer Chechi, you were talking about.
I was wrapping up and saying that if you want global impact, come to the aviation sector. Come practice your engineering in the aviation sector, and then of course, because engineering in the aviation industry is the arrival of any nation to its developmental goals, and so that's just it. Thank you very much for your time. Thank you so much. Thank you for always coming out good anytime you appear on this program. Thank you so much. And you're not going yet, but we would like you to quit your slides so that we can see your face. Then you can answer a few questions. Okay.
A few questions before we round off. First of all, I would like to. Some engineers would sue you for for what you said about young people should come to aviation engineering. But I would like to ask if after studying maybe mechanical engineering or electrical engineering, and anybody wants to specialize in all these fields, you talked about aeronautical engineering, aircraft maintenance, aeronautical telecommunication engineering, and all that. What would be the next step, just for information's sake?
Oh, okay. For a mechanical engineer, you can choose to either be an aeronautical telecommunication engineer, that is, you work in the power systems. Remember, I spoke about the power systems. Or you're an aircraft maintenance engineer. Now, if you want to be an aircraft maintenance engineer, you can, after your degree, you can go to like the college in Zaria. And so you do an abridged, just 6 months. And then you take some exams. Remember, this field, because we're dealing with lives, it's highly regimented, if I'll use that word. So you take exams and you must pass. 80% is the minimum, before you are allowed or permitted. So you do a 6 months course and then take all the exams with the Nigerian Civil Aviation Authority after passing the one that the school will present to you. And then it's a beautiful field, actually. You log and then take more exams before you're now allowed to, release an aircraft. That's how they call it. So it's only a licensed engineer that will release the aircraft and say, oh, this aircraft is safe for flight.
All right.
Okay, so it depends on what you want to do. Thank you.
Is there a space for mentorship. For example, someone that has just finished from the aviation school and is sitting in the cockpit for the first time. Is there a space for mentorship in all of this?
Yes, there is, definitely. Engineering is a field where you work in teams. So nobody's going to leave you behind. We actually even have some of these airlines allow for what we call on-the-job training, OJT. You know, of course, if they have the funds, they pay you a transportation allowance. If they do not, they don't, because you're actually learning, and it's for your own good. So there is always a space for mentorship. And then the Nigerian Society of Engineers, the Association of Professional Women Engineers, and a whole lot of engineering bodies do a lot of this mentorship. So they won't be left alone.
All right.
We can't afford to leave them alone. Yeah.
Okay, I have two more questions for you. First of all, it's been said that every knowledge expires maximum 6 months. Is that so in engineering, in aviation engineering? And how do the branches of engineering in aviation keep tab with the new trend, as it were?
Will I agree with 6 months shelf life? No.
Okay.
Because if you didn't have that old knowledge, you can't build on the new. So I wouldn't use the word expire. I would just maybe use the word, it moves to, what mode will I call it now? Inactive mode, right? So yes, like I said, the aviation industry is knowledge driven. It's knowledge driven, emphasis on knowledge. So we have to always keep updated. We have to keep doing licensing. We renew your license every year or it depends on what license you have. But you renew it means you go through rigorous, trainings again to make sure. And then even like, for instance, the pilot who flies, they must always consult their manuals, their books. If they are experts, they are captains, but they will. The same thing in engineering. They always must go according to the manual, even when you are an expert. So yes, we have to keep reading. A lot of us wear glasses, actually.
So it's a sign of how much you have read. All right, lastly, safety. How important is safety in aviation engineering?
It can't be overemphasized. Safety is critical. It's been a while we had an air crash or an accident that, took lives. And you know that if an aircraft crashes and maybe lives are lost, you're talking of, depending on the size of the aircraft. So it's safety, it's a safety conscious. Everything we do it for safety. Everything we do it for safety. So it's something you breathe. It's like the air we breathe. So it's highly safety critical sector. We don't joke with it. And that's why you do a lot of documentations. You don't rely on, oh, I know it. Yes, you know it, but what does the book say?
All right, Engineer UCHECHI, EDOSOMWAN. I hope I got that right. Thank you so much for joining us. You're actually the first guest that will be joining us back to back on engineering and you. Thank you so much for doing justice.
Thank you. It's a privilege
to this topic.
So thank you.
And hopefully when we call you some other time, you'll be here. And hopefully you can just join us in the studio also. Thank you so much for joining us.
No problem. Thank you very much.
All right.
For the privilege.
Our time is almost up, and we have to go now. And before we go, Glory from Owe, you got our questions correctly. So pick your phone and call this number 0703 161 1497. The answer is active transport. And for the question for the week, as we go, plant synthesized protein from what? Plant synthesized protein from what? If you know the answer, our social media handles is where you get it back to us. We would